Alhamdulillah, wassalatu wassalamu ala rasulillahi wa ala alihi wa ashabihi ajma'in wa ba'd. Alright, that's great. Let's start our session for today, and we are studying normal distribution today. And previously you have studied binomial and geometric distribution, which were discrete. They were discrete distributions, which means that they had fixed set of outcomes. So it could be either 1 or 2, nothing in between, integer data. But today what we are going to study is normal distribution, and it is continuous data, which means that the data can have, there are infinite number of possibilities for which the data can have, okay? So the first condition for the normal distribution is that it should be continuous data, that is outcomes. What are some of examples? We have length of leaves, we have height of students. So is there any fixed set of values that within which you could restrict the heights of students? Is it possible? You can have a particular range, but the very specific value is you cannot restrict it to a limited set of values, okay? Only a fixed set of values, let's say 150 and then 150, how 150.5, 150.25, how much, how longer can you go? You can go for infinity. You can say someone's height is...
I couldn't catch the point. What you said about the infinite number of outcomes.
Yeah, so let's say we are trying to measure the height of a student, and let's say student A has a height of 50.5 centimeter, student B has a height of 50.475 centimeter, student C has a height of 151.32. How many possible how many possible values can you have? Is there any limit? You could go till infinity. 150.4751 and then or 52 or 3, now you understand?
Yeah, I get.
Yeah. So these types of data are called continuous data, as opposed to discrete, which has fixed set of outcomes. For example, I am rolling a dice, okay? And what is the set of outcome? It could be either of 1, 2, 3, 4, 5 or 6, fixed set of outcomes. It could never be 2.5 and let alone 2.555 and blah blah blah, okay? You understand now the difference? So this type of distribution, normal distribution, is continuous data. Some examples could be length of leaves, heights of students, okay? It could be any value between 150 and 151. So this is the first condition for normal distribution. Usually it comes around 15 marks with 2 questions, this is the usual. And the second condition or the second characteristic for normal distribution is that it has symmetrical data. Symmetrical means data is divided evenly on both sides of mean. You remember line of symmetry, Hamad?
Yeah, I do.
For example, if you have a shape and let's say you have a parabola here, and if we know that the line of symmetry is the same as x equals to the vertex of it. So what is the purpose of line of symmetry? It divides the entire thing in exactly 2 halves, right? Such that one side is a mirror of the other side. So similarly, symmetrical data means data is evenly divided on both sides of the mean. So this is an example of the normal distribution. This is how we visualize or represent normal distribution graph, and area under the graph represents probability. So area under the graph of the right side of this thing is 0.5, and of the left side is 0.5. Total, we know that the total probability cannot be greater than 1, right? So that's why the total area is also is equal to 1 and will not be greater than 1. So mean is in the center, okay? At z equals to 0, we'll explain what does that means in a moment. But here is what we mean by data is symmetrical, but data is evenly divided on both sides of the mean, okay? So this is the mean, and area under the graph represents probability. I know it doesn't make any sense now, but you will understand the reason for all of this, okay? So this is the second one, and for the third one, the condition is n is large. We will discuss later on it in the chapter. What does that mean? So these are the three conditions via which you will understand that this is a normal distribution question. I mean, you have to apply normal distribution. It is always given when you have to use the normal distribution in the question. So this is a plus point. Earlier we had to identify first whether this is binomial or geometry. The question never explicitly stated us, but here it is always given when you use the normal distribution in the question, so you don't have to worry about that. All right, so we'll understand it using an example. Here is an experiment where we are trying to get the heights of a students in a class. Okay, so let x represents the heights, which is the data, and so if you want to find the probability, we know that we check the area under the graph, right? So this is what we represent heights data, and this is the mean, this is the function of x, and we know that the area is the probability is area under the graph. Now here is the problem with this. Every time you do a new experiment, a new graph is to be made. Finding area under graphs is complicated, isn't it? Like each time you have to create a new graph and stuff like that.
Easy, like you could just do integration.
Yeah,
Graph.
but you could do integration, but the fact that each new experiment requires a separate graph. So math people didn't like this at all. I mean, we wanted a standardized version, a same graph that could work with all experiment, but we, after some calculations, if we can convert all the graphs of different experiment into one standardized graph and then make our calculation from that, it would be much more like standardized and much easier. So that is the reason maths people invented something called Z table. So we designed a standard graph which can work on any experiment, that is called a Z table. So whenever we have an experiment and we have the data, we use a formula to convert it to z value, and then we use the standard table plus graph to find the probability. What does that mean? This is the table that I'm talking, and it is given in the exam. So if you want to find this, you just go to the Google and just write MF19, and if it doesn't appear, then write FM19 Cambridge, and here you will find this list of formulas and tables, and on the 10th page you have the normal distribution function, and this is what we require now. Okay, so this is given in the table. Let me explain what does this table represent. Please listen attentively. Here what you see here in this row and in this column, the first column, this this thing is the value is the value for z or z values. Okay, and inside the graph represents probability. All of these are probabilities, and see that probability is starting from 0.5, and see that the last probability is almost closer to 1, and we know that the probability can never be 1, and I will explain what does this add mean in a moment, don't worry. So this is what the normal distribution function represents, and we know that the normal distribution curve is equally distributed. So you have 0.5 on the left side, the area under the graph on the left side is 0.5, and the area under the graph of the right side is also 0.5. So now we introduce our figure Mrs. S1. This Z table always tells area to the left of the Z value. That is the reason it starts from 0.5, because when you have Z0, listen carefully, when you have Z 0.0, the area is 0.5, which means Z only starts Z starts from here, and this graph is only defined for positive values for Z. Z starts from 0.0 and it moves on from here 0.1, 0.2 and up until 2.9. We don't have negative values for Z in this table. So
so here Z is the values of x-axis, right?
Yeah, Z is the values of x-axis.
So why doesn't it start from 0?
It does start from 0. 0.0. Okay, so I will teach you how to read this table. You might be confused by seeing this table, but here it is. Like, this is the x-axis z, and this is the value for 0, 1, 2, 3, and this is a different function. I don't want to name the function. I think it's called the CDF, if I'm not mistaken. Cumulative distribution function, yeah, or it could be the PDF. Never mind. We're not interested in the function. We just know that the area under the graph represents probability, and this is what we are trying to this is what we will do. Okay, so this z table always tells area to the left side of the z value. So for z equal to 0, what is the area of the left side of the graph? It is 0.5. For z equals to 1, what is the area of the left side of the graph? We will see in the table. So always make sure to remember this, and we'll see what does that mean. Okay, so first let's learn how to use the table to find probabilities. Okay, so let's say they tell us to find the probability that z is less than 0.54. Okay, so this thing represents first decimal place for z. Again, this column represents first decimal place for z. So we are told to find 0.5. So we go to the table and locate 0.5. Then they said 0.54. This thing represents second decimal place. So we go to 4. So 0.54 means this probability value. This is the probability value we're interested. 0.5, this is 0.4, and this is third decimal place. We were not provided with third decimal place, so we will not see here. But I think you understood how. They have asked us to find the probability of z is less than 0.5. So z is located here, right? And we know that the less than 0.5 means the left side of the graph, and we know that the z table provides us area to the left side of the graph. So we located this thing and we found the value of 0.7054. So which means that the area for the left side of the graph is 0.74, and hence the probability is the same as area. So probability z is less than 0.54 is equals to 0.7054. Please let me know whether you have understood or not. Is it clear? Yes, no?
We find the answer from the table, right? Directly, there's no multiplication, no addition, nothing.
Sorry?
We find the probability directly from the table given. So there is no addition, multiplication, nothing involved.
At this stage, not yet. There will be some addition in the third place. Did you understand what I have said here?
Can you show the table one more time? To the probability we have to find, right?
The area of the graph is equal to the probability, yes, and this table gives us the probability to the left side of z value.
So Mrs. S1 is standing at the point where the value is 0.5.
Exactly, z equals to 0.54, and they have asked us to find the probability of z is less than, and the table also gives us the area of less than, so that's why this is our probability.
So shouldn't we just add the left part of the graph, like the one that is in negative part, 0.5, and add it?
But the table already provides you the the area for the left side until infinity. This is not from 0. I understand your confusion. You thought that the table is providing the area for up until 0, and so you have to 0.5. That is not the case. That is the reason why the table starts with 0.5. when you have a z value of 0, what is the value? 0.5, which means the left side of it is already included. You understand?
Yeah. So you could just minus the 0.5 part and find out the area that is like in the right side.
Yeah, but there is not, like, yeah, you could, but there is no purpose for it. Like, why would you do that? Like, this does not represent any significant thing. Yeah, technically yes, if you were interested in the finding that area. But as far as I know that this does not represent anything, or it is not useful in our any calculation for probabilities in any way. So anyway, that's great that you have reasoned a lot and understood. So can you give this one a try and try to find the probability z is less than 0.345? Okay, so this is 3 decimal places. I'll give you a hint. You know for the first 2 decimal places, what do we know? What do we do? Tell me. What do we do? 0.345.
Find the corresponding, like, the value from the table.
Yeah, 0.3 and then 0.4, right? 0.34. So what is that value? This is the value. But here's the problem. 0.6331. We also need a third decimal place for 5. In that case, what we will do is we'll go and find the third decimal place here, and we see a note called add 19. Add 19 means you add 19 with the last digit of the thing that we have found, and you add this. So which means this becomes 3145 36 0.6 6350. This is how you deal with 3 decimal places.
Very good, very easy.
Let me know you have understood or not. So again, very interesting. Again, they have asked us to find the probability for left side. Z is less than, and that is the reason the area that we have found is the same thing for this, and we can say that the area of the under the graph represents the probability Z is less than 0.375, which is the area that we have calculated, 0.6350. Are we good?
Yes.
So if you understood that, how would you find this one? Probability of Z is greater than negative 0.47. Could you give this one a try? Okay, wait. Let me give you an easier one then. Try this one. Probability Z is greater than 0.18. Probability Z is greater than 0.18. Try. Yes, indeed, you are correct. Now they have asked us to find the probability x is greater than 0.18. So what we do is we locate the z value 0.18, and then we find the value for 0.18, and we find the area of 0.5714. Now we know that the table gives us area to the left side of the z table, but we are interested in finding probability greater than, which means we want this area. How can we find that? We subtract it from the total 1 minus 0.57, and then we say probability Z is greater than 0.18 is equals to 0.4286. You understood?
Yes.
Okay, now can you try and find probability Z is greater than negative 0.47? How do you deal with negative 1? We don't have any negative values for the like in the Z table. So how do we find the probability for Z is negative something? Well, let me show you the first one. We know that the table is symmetrical, right? It is symmetrical. So what we can do is we can flip. So Z is greater than negative 0.54. No problem. We don't have any negative value. There is no negative Z values on the table. So what we do is we can use the symmetry of the graph. what they have asked us to find probability z is greater than this thing, so which means we are interested in finding this area. What we can do is we can flip from negative 0.45 to positive 0.45, and this area will represent the exact thing because they are symmetrical. Now we go to the table and just find the area for 0.47, and when you find the area for 0.47, we get this thing, and this is also the same thing for z is greater than negative 0.47.
I have understood the concept.
Okay, you have understood the concept. That's great. Then can you try and find out? Let me see. Yeah, try and find out z is less than negative 0.36.
Which one should we?
Probability z is less than negative 0.36. This one. Are we good?
Is the answer 0.3594?
Exactly. The answer is indeed 0.3594, and here is how I solved it. So they have asked us to find probability z is less than this thing, so which means that we're interested in finding this area, but we have to flip the diagram because our table doesn't provide any value for negative z value, so we flip it and find 0.36. Now we know that table gives us the area for the left side. In order to find this side, we need to subtract it from 1 again. So always when you flip the diagram, first shade the region and always like shade the corresponding region, which area, which portion we are trying to find, and then you write the final answer. Probability z is less than negative 0.36 to be 0.3594. Did we understand it correctly? The procedures,
Yes.
everything? Okay. Now here is one important note. In normal distribution, x is less than 45 and x is less than equals to 45 are exactly the same. But remember, in binomial and geometric, x is less than 45 and x is less than 45 are two separate ideas. You know why? Because we know that binomial and geometric distribution can only have integer values. So when I say that x is less than 45, which means what? What are the possible values for x? It is 44, 43, 42, 41, but not 45 included. If I have said x is less than equals to 45, then what is the corresponding value for binomial and geometric? X is 45, 44, 43. Big difference. You see, here we didn't include 45, but here we include 45. But that is not the case for geometric distribution because it doesn't make any difference because it is continuous data. X is less than 45 and x is less than equals to 45 are they exactly the same, because like there is not any fixed amount set of data. X is less than 45 means 45, and 45 less than, so 49.999999. How long can you go? So it doesn't make any difference. You understand?
Yes.
Okay, now we are interested to find probability. Find the probability that z is greater than 0.23, less than 0.89. How exactly do we find that? So for the very first thing is you shade the region. We're interested in finding this thing, right? 0.23 to 0.89. We're interested in finding this region. What we can do is we find the table value of 0.89, and this is how you represent table value. You have to write it in the copy. You have to show the rough. This sigma is used to represent table value. So this means table value of 0.89 equals to this thing. So if you find the table value of 0.89, it will give you area for this portion, right? And if you subtract it from the table value of this thing, which gives you the area of this portion, won't you find the area for this one? So table value of 0.89, you find it, 0.89, you get this, and 0.23, you find this. Table value means this thing, I've explained to you. And finally, you can say that the probability for z is between these two values is a subtraction for these two table values. Please let me know whether you have understood everything clearly or not.
Yes, we did understand.
Okay, that's great. Then I have this for you to try out. Okay, let's see what is the answer. The answer is 0.2589 indeed. So this is my working. This is how I have solved it. Let me know whether you have solved it in a similar portion, in a similar way or not.
In exact similar way.
That's great. So it means that you have already understood it very well. So here is another advanced problem, a bit advanced. So give this one a try and let me know whether you can solve it or not. Well, here is the answer. It is 0.2635. So this is my solution and working. Please confirm and let me know whether you have solved it in the similar method or not. Do you need my explanation?
No, I got the procedure.
You got the correct answer as well?
Yeah, I told the answer 0.2635.
Okay, that's great then. So shall we move on?
We may.
Okay. So the questions for this chapter are usually categorized into 3 types of question. The first type is forward working, then we have something called reverse working, and then we have something called normal, binomial to normal approximation. As you have seen in the session description, today's session is mainly targeted for forward working. In the next session, second session, we will deal with the type 2 questions, and on the third session, inshallah, we will deal with the type 3 questions. So what is type 1 questions? Like, what does that mean? Forward working. Well, basically, you will have, like, they will give you data, okay, X, and like data will have mean and standard deviation, a set of data. And you use the formula z equals to x minus mu over standard deviation, where x is data value, like height, etc., whatever the data is, mu is mean, and sigma is standard deviation. So use the formula to convert to find the z value. Did you notice one thing? All what we have solved here, they have given you the z value. Like here it was, the z value was given, but in the question they don't give you the z value. So you first need to calculate the z value from the given data, and then you have to find the probability. So they will give you the data, and sometimes you also need to calculate mean and standard deviation by yourself as well. Sometimes you don't. They're just provided in the question. You use z equals to x minus mu over standard deviation. Use z values, find the diagram plus, use the diagram plus table to find the probability. Do you have anything to say?
Yes. Could you please show the z value that was given in the previous question? Like, I couldn't find any z value. What is z value?
Here z value, find the probability for z is greater than negative 0.12 up until 0.5 c. This is z value. What are you talking about?
Yeah.
It's the same z value that we're talking about. So now, here's the thing. This is a question. X is normally distributed such that X has mean 36 and standard deviation 12. So we taught you the symbol mu equals to 36, sigma equals to 12. In S1, we write all probabilities to 4 decimal places. Okay, find all z values up to 3 decimal places. You see, z value has 1 decimal, 2 decimal, and 3 decimal places. So always be consistent with that. And did you notice that all probabilities are written to 4 decimal places? So please try to maintain this thing. Now they have asked us to find the probability of x is greater than 38. Whoa. Did you see the difference? Like all these previous questions, they were talking about find the probability z is greater than, less than, z is greater than, less than, z is something. But now they're telling probability x is greater than 38. So how do you find the how do you find that? Again, use the formula. We know that z equals to x minus mu over standard deviation. So you convert it and find it to z. How? This is the value of x, so put it here. So z equals to x minus mu over standard deviation. Mu is given, standard deviation. You find the value of z to 3 decimal places. Did you understand up until this point?
Yes.
Now they have asked us to find probability of x is greater than 38. So we replace that with probability x is greater, z is greater than the value that we found, 0.167. And then you use the normal procedure to find that. Like you find the table value of 0.167. It gives you area to the left side, but we are interested on the right because greater than. So you subtract that to find the probability. And because it's a 3 decimal places, you need to use this thing, add 28. So add is only on the last 2 digits. Okay. So don't add 28 as a whole. Probability can never be greater than 1. Okay.
That would be a problem.
Yeah. So please go through this thing and let me know whether you have understood the entire procedure or not.
The value that we convert from x to z is greater than 38, but what if it's like greater than equals to or something?
It doesn't matter.
Doesn't
I already taught you previously that in normal distribution, greater than equals to and less than equals to is the same thing, so it doesn't matter. Same answer you would get. Any other questions or confusion?
No more questions.
In that case, please try and solve this thing. Probability x is greater than 32. And you need the mu. Here is the mu. I'll give you. Do you need the formula as well?
Formula? Yeah.
So we have solved the first one. Now you solve the second one. Okay, z equals to x minus mu over standard deviation, sigma. Try and solve the second one. Okay, so let's see. This is the answer. 0.6304. So I guess you solved it using the same procedure since you have got the answer correct. And yeah, that's great then. That's great that you're able to solve these types of question. So do you have any confusion or question? Do you want me to explain it? Anything?
We don't have any more further queries.
In that case, please try to solve it and let me know the answer as soon as you are done. Do not waste any time doing anything else. Well, here is the answer. Well, Well, here is the answer, yeah. So, final answer is 0.4471, and as you can see, always write the final answer like this. The initial thing you were asked to find 0. Probability x is greater than 32. You do calculations and then finally say that this is the answer. Do you have any confusion or questions? All right, so that's great. So then next question is to find part 2 for this one. Okay, so try and solve this part 2 for the same question. I think you're wrong. Okay, so what were you doing in the previous questions? Here you replace the x with replace the x with z.
32 is the mean, my bad.
32 is not the mean, 30 is the mean. So when they have asked you to find probability x is greater than 24 and less than 30, you just replace the z value for 24 with the thing and z value for 30 with this thing, and then z, you find the probability z is greater than negative 0.4 and less than 0.4. You shade the region here, you flip the diagram for positivity, you find the table value of 0.4, and you don't need to find the table value of 0.0, right? You know it 0.5, but yet if you want to find the table value for 0.0, it's here 0.5, and then you subtract this thing from like 0.5 from this thing and you find the answer.
Just minus the probabilities, that will give the same answer, right?
Minus what?
Minus the two probabilities, like 0.6554, which is for 0.4 and 0.5.
And 0.5, yeah. If you subtract this thing from this thing, you will get the shaded region, and this is what we are trying to find in this question. You have to subtract. Here it is shown here.
Yes, we are done.
Okay, so similarly, if you were to find this thing, how would you solve that? The same thing. First, you convert z equals to x minus mu over standard deviation. So we know that x is 28 minus mu is 30, if I'm not mistaken. What is mu? 30, and standard deviation is 15. 15. So what do we get? 28 minus 30 over 15. Please let me know. And also x equals to x minus mu over standard deviation. So 34 minus 30 over 15. So what do you get for 28 minus 30 and
minus 0.133?
And this one, 34 minus 30?
0.267.
0.
0.267.
So now you understand what you have to do. You just replace this thing with 0.133, and then you replace that with z, and we replace this thing with 0.
Minus 0.133.
Minus 0.133 minus 0.267. Yeah, you're talking about basically this thing, and then you would be able to find the next thing using the same procedure. You get the idea, right?
Yes.
Yeah, that's great. So that's great that you have understood everything, and now what we would do is now we would actually move on to practice real past paper questions for the type that we have learned today. And this is the first one. Please let me know as soon as you are done finding the answer. You don't understand standard deviation. Standard, like they have given you like not like, oh, I didn't taught you this. Now I get it. So here is the key. So you understand, like previously, when we learned binomial, we represented binomial distribution with like x, and this thing means distributed. X is distributed binomially, and we had np. N means number of repeats and probability of success. So when they said, example x is distributed binomially 12, 0.2, what does that mean? N equals to 12 and p equals to 0.2. But in normal distribution, this is how we represent, and x is distributed n, mu, and standard deviation. So this thing is mean and this thing is variance, not standard deviation. Be careful, this is variance. So which means what? Mu is 12 and sigma square is 36, which means sigma is 6. That means sigma is square root 36. Similarly, if you have understood this, then I think you would be able to solve this question. They have given us mu, which is negative 15.1, and sigma squared to be 62, which means standard deviation is root 62. So now you understand how to solve this question? Okay, then please try to find the final answer. Well, the answer is 0.0276. You forgot to subtract it from 1. They wanted us to find the probability x is greater than 0, above 0. So you find the table value which gives us the left side of it, and we have to subtract it from 1 to find our final answer to be 0.0276.
My bad.
You understand the mistake now?
Yes.
Shall we proceed to the next question?
Just a minute.
Okay. Here is the solution for this question. The final answer is 0.7285. Did you solve in the same procedure that I've shown here?
Yes.
Yes.
And you got the same answer as well. So shall we move on to the next question? We'll have one more question for today's session. Okay?
Okay.
Okay.
So this is the last question for today's session from type 1 questions. Which part of the question are you finding the difficulty? They have given you mean, mu, and standard deviation. If 800 observations are taken from the distribution, 800 is the total number of observations, it means n. How many would you expect? So here they're asking us to be find the expected value. You remember the expected number mu? Expected means mu basically equals to np. Do you remember? Expect how many would you expect to be between this thing and this thing? So this is a sort of sense of binomial though, like expected value number mu, expected number was equals to np. We studied in binomial distribution anyway, but you have to first find the probability. They have given us the value for n, which is 800, but we have to multiply that with p. So how would you find the probability? So they are basically see the question. If 800 observations are taken from this distribution, how many would you expect to be between this thing and this thing? So they're telling us to find the value of x. Between means greater than mu minus standard deviation, less than mu plus standard deviation. So you convert it to z. You convert it to z by using mu z equals to x minus mu, and then you plug in here x. So mu minus standard deviation minus mu gets cancelled out, negative standard deviation means z equals to -1. Similarly, you plug in this value to x, mu plus standard deviation minus mu, again plus minus gets cancelled out, and standard deviation upon standard deviation is 1. So this entire thing gets converted to probability of z is -1 to less than 1, and then you would use the table and the graph diagram to find the value of this probability. Can you find the probability now?
Yes, of course.
Then just ponder over what I have said. How did I get this? Ponder over the question, and if that you shouldn't memorize this. Understand that whether this really makes sense, and find the remaining portion of the find the remaining solution then. Okay, so the probability is 0.6826 and final answer is 546. How many would you expect? Okay, from 800 observations, it is integer, so final answer should be 546. Okay, we know that probability of for any expected thing is expected divided by total, right? So now they are asking you to find the expected value, and you find the probability and you multiply it total. You could think of this way as well, like how did we get, why are we multiplying the probability for greater than mu minus sigma, less than mu plus sigma? Why are we multiplying it by total? You could also think it this way. Either you could think it this way, expected number, or in this same way, like in this way. Please ponder over the solution and let me know you have understood everything wholeheartedly or not.
Yes, we have understood everything.
And you got 546?
Yes.
Alright, that marks the end for today's session. If you have any questions from any portion of the Lecturer, you are most welcome to ask. Otherwise, you're free to leave.
Thank you.